Okay, this video representing about how to calculate and how to find the value of current across through each resistor in the following circuit by using Kirchhoff Law calculation method. Okay, just follow the sequence of the calculation method. For the step 1, we define the direction of the current voltage polarity first. Okay, by referring to the electrical circuit given here, we just estimate the direction of the loop and also the direction of the current is clockwise. This is because Kirchhoff Law states that the unknown current are usually defined in clockwise direction, while known current are defined according to the direction of the current source. So we know the current source here is batteries. And the principle of electron motion inside the batteries is always from negative terminal to positive terminal, or from the lower stage to higher stage. This is why the direction of the loops we declare it as a clockwise direction. Step 2 is apply KCL, Kirchhoff current law. This law is also called Kirchhoff junction rule or Kirchhoff point rule. This law states that the sum of the current entering any junction of wires must equal the sum of the current leaving that junction. That is why total I in should be always the same with the total I out. So the equation is I1 equal to I2 plus I3 for the equation 1 after we applying KCL principle. Okay, step 3 is apply KVL. By referring the loop in the circuit, this law is also called Kirchhoff loop rule. It is a consequence of the principle of conservation of energy. It states that the sum of the voltage potential difference across all the elements around any closed circuit loop is equal to 0. So we find the equation here for the loop 1 and the loop 2. Loop 2 and loop 3. Okay, we move to step 4. Express in voltage function. As we learned before, voltage function is referring to the Ohm's law rules, which is voltage is equal to IR, current times with resistance. So for this step, for the equation of loop 1 and also the equation of loop 2, we expand the terms of voltage in the equation of loop 1 and loop 2 with IR. So the value of R here already given in the question, which is R1 is equal to 1 ohm, R2 6 ohm, and also R3 is 2 ohm. And we insert this value of resistance inside the equation 2 and equation 3. And we get the new equation here, and we declare it as a equation 4 for loop 1 and equation 5 for loop 2. Move to the next step 5 using KCL, where I1 equal to I2 plus I3, equation 1, because of I1 is inside the equation 4, so substituting equation 1 into equation 4, just replace I1 in the equation 4 with the equation 1. So we get the new equation here for loop 1. I2 plus 7 I3 equal to negative 5. And we declare it as a equation 6. So the next step is solve the simultaneous equation between I6 for loop 1 and I equation 5 for loop 2. Okay, we modify the equation of loop 1 in terms of I2 and substituting this equation I2 inside the equation 5. And we get the value of I3 here is negative 1 M. And by using this value of I3, insert this value inside the equation 6. And we get the answer for I2 is 2M. And by using the value of I2 and I3, we get the value of I1 by using equation 1. So the sign here for the value of current obtained, positive shows that the direction that we assume yearly is the same with the actual one, and the negative sign shows that the assumed direction is opposite with the actual one. So that's all. Thank you.